So now we're going to find an equation for a negative a-valued even degree function. This is probably a quartic. Quartics look like a W. So we've got even degree, and we have a negative a value because it's going down like a sad face parabola. So first thing I do is work through what my x-intercepts are. I've got here at -3, so it's going to be x plus 3 gave me that root. But to get it to bounce off, I got to give it an even degree. Just a nice little term like that's going to be a squared. Same thing over here at +2. It came from a factor of x minus 2. And then you got to give it an even degree to produce that root of 2. So our job is to say f of x is equal to this function that I'm not sure about the a value. Don't put -8, just put a, and then we know the result's going to be negative when I get there. And then we have x plus 3 squared times x minus 2 squared. And so what I do now is use a coordinate, pretty easily identified right here at the y-intercept, as 0, -12 to find the a value. So I say f of 0 will produce -12. So that's equal to a times, and you put zeros in for the x's, so it'll be 3 squared, put a 0 here for this one, and that's going to be -2 squared. And then we just have to work out and solve for the a value. So this is going to be 9, that's going to be 4, so it's a times 9 times 4 equals -12. Continuing, we get 36a, it's 9 times 4 is 36 there, with the a in the back, equals -12, and then you divide both sides by 36, and reduce if possible. And here we get a equals, divide the top and bottom by 12, and we should get -1 over 3. So that a value goes right here in front of the rest of my factored form for a final f of x form of -1/3 times x plus 3 squared times x minus 2 squared.